Hello Internet, welcome to the very last level of the Ethernaut series for me. There may be new levels that are added after this video is published, but it's the last one for me. I may come back to the new levels when they're published, but for that being said, let's conclude this bad boy. So with this level, warning, I did not complete the implementation of the solution. So there is no actual answer that I'll execute on. I'll walk you through the exploit for the contract. I'll walk you through the specific code that I came across that's useful to help you implement the solution, but I didn't go about doing it myself. Reason being is that you'll see that this level specifically is kind of like an infomercial for Forta. And this Forta concept is really interesting. So they're basically trying to create some sort of detection bots that it's kind of like a SIM on the blockchain. So if you know what a SIM is in security, it's basically setting up a SIM where you can trigger on events that happen on the blockchain that let you know something happened that probably shouldn't. And they have these little things called detection bots that do that. This is cool and interesting and all that great stuff, but it's not where I want to spend my time and my attention. And I have included some quotes in here to rationalize my reasoning to you, which probably isn't needed, but I'll do it anyways. So first, we have an image here that I wanted to explain. This image is something I think about pretty consistently, which is basically you have a ladder and you're climbing this ladder. So climbing this ladder could be climbing the ladder inside of a company. It could be climbing the ladder of intellectual understanding of a certain topic. It could be climbing the ladder of your ability to be more self-aware and meditate, whatever it is. And sometimes when you're climbing a ladder, that ladder sometimes is sitting on the wrong wall. And your intent was actually to get to the top of this wall, but you're actually aiming this way. So it's understanding that even if you're moving and progressing forward, are you progressing forward in the right path that you initially intended to go towards? So that's one thing. And then there's a good quote here that basically it's the successful person places more attention on doing the right thing rather than doing things right. So this is basically getting the same point across. So paying attention to the right thing instead of doing things right in the wrong direction, which kind of comes back to this wall thing. So that's my rationale of thinking through why I'm not going to finish this, because I have more things I want to learn and there's tons and tons of stuff to learn within Web3, and I want to focus my attention on the things that I genuinely am interested in and care about, and creating detection bots with Forta is not one of those, at least not now. So that being stated, last level, super pumped. Let's get through this. All right, so game over, last level. This is the end, and I came across two solutions that I found useful here. But before we get into that, let's actually talk about the challenge itself. I'm not going to read through the entirety of this thing, but I'm going to kind of point out the things that we need to care about. So first off, the first part of this challenge is basically to find the bug inside of Cryptovault. So there's some sort of exploit that we can take advantage of inside of this. And what we want to do is basically do what it says we're not allowed to do. And here you can see that there's a function called sweep token, and that allows us to basically sweep the token. So transfer out token from the Cryptovault. And it's going to allow us to sweep out legacy tokens. So this is what we're allowed to sweep out, but we're not allowed to sweep out the DET tokens, which basically is the underlying token that they call it an underlying token. You can see it here. And this is something that's not supposed to be touched. But we'll find out quickly that when we sweep this token, since this is based on this, we can actually sweep this as well. So that's the thing we need to take advantage of in the exploit we need to execute on. And then after that, there's actually another piece here where basically they state that your real job here is to actually set up a detection bot in accordance to Forta. And that detection bot needs to basically trigger an event anytime that a potential attack or exploit occurs when someone's trying to sweep out the DET token, when you're not supposed to do that. So that's the overall challenge. And there's quite a bit of code here. The reason there's a lot of code is because they've included 4 contracts into a single blob of text. So we will look at all of that text. Now, what I'm going to do here is I'm going to review the code for the challenge. I'll highlight the function that is the function that we're going to exploit. I'll then point you towards the solutions that I found useful, and specifically some bot code that I found that was the most intuitive to understand how the bot detection piece works. Coolio. All right, so we have our code here. per usual. So we have our Solidity Pragma set up, and it's 6.0 and above. Remember, floating point's not good, so don't use it. We're importing a few things. So the first thing we're going to import is ownable. So we can set up a modifier that allows us to interact with something through via access control only the owner can access. And then ERC20. So we can, set up an ERC20 like token, which is going to be, I think it's going to be DEET, and then LGT is the other symbol. And those tokens are going to create initial supplies and have all the great things that comes with ERC20. So now we have a series of interfaces. So we have an interface here, okay, 3 interfaces. So this interface is referring to the ERC20, and it's an interface to delegate the transfer to the ERC20. And you'll see where this comes into play later on. So what this interface is basically exposing and showing is a specific function that does the delegate transfer. And it's going to say, okay, you can transfer to this address, you can transfer this amount of value, and you can transfer from this sender. It's external, and it returns a Boolean if that worked or not. The next interface is the detection bot. So this is the detection bot that we're going to build out. And what this detection bot has inside of this function is basically handle a transaction. That's going to say, okay, the address of this user, and then this is the message data that it's going to basically push out the detection bot. So the interface for Forta is basically configuring configuring this detection bot via what Forta has set up here. And their interface, what it's exposing is basically your set detection bot. So it's saying I want to set the detection bot to this address. So that's kind of like the implementation. Like the analogy I've kind of thought through here is basically for the proxy pattern, you have your proxy and your implementation. Your proxy points to the implementation. Kind of process applies here. So you have your detection bot and you're pointing to that detection bot. Notify is basically notifying the user when something happens. So the person who needs to be notified. So the person we want to notify is the user that's kind of watching over the detection bot, and this is the message data we're going to send to them. And then below that we have the raise alert. So this is basically when the alert triggers, and when it triggers, it's going to trigger to this individual. So those are the interfaces. Now let's go below here and start walking through the contracts. So I'm going to kind of peruse these pretty quickly. The reason being is, like I said, I dug into the code, but I didn't dig enough to basically implement it myself. But with that being said, you know why. All right, contract. So this contract is called Forta, and it's inheriting the interface we discussed above. We have 2 state variables, 2 mappings. So this mapping is user detection bots, so the number of bots that were created by a user and what address is associated with that. And then we have the raised alerts that occurred. So that's basically going to show you the number of alerts that triggered for a specific bot. We have a function, set detection for bot, okay, notify and raise alert. So these are all the pieces we just discussed above in this interface that's exposed. And this is basically more detail into what's happening there. So we can see for detection bot setup, we're going to put in an address. All of these have overrides, which is basically due to the interface above. We're going to override those. Or be overridden. And here you can see it's basically checking to see that the address is matching the user detection bots, and that needs to ensure that the detection bot is not already set up. So if it is, then it'll skip it. So that's making sure the detection bot exists, and if it does, then skip. If it doesn't, then create one. Notify, it's basically saying that we want to ensure that we're notifying the right person, so we're going to go to the detection bot users. If that address equals 0, then continue and do what we would like you to do, which is basically handling the transaction, sending it to the user, and sending the specific message data we want to that user. If not, then it'll catch it and throw it into this curly bracket. Raise alert. So raise alert is simply saying it's going to trigger an alert. So if the user is not the sender, then don't trigger the alert to that address. If so, continue and trigger that alert and then add it incrementally to the number of alerts that were raised. So that is our Forta contract. Next is Cryptovault. So this one doesn't actually have the exploit inside of it, but it has parts that will be leveraged. So Cryptovault is not inheriting anything. We have an address, which is the sweep tokens recipient. So when you sweep the tokens, who's getting the tokens and where is it going to? We have ERC20 underlying, so the variable is underlying, and then this is basically taking on this ERC20 interface. constructor. So we're going to basically say the recipient, whoever deploys this Cryptovault is going to be the recipient, or whoever sets this up. So when you deploy this, they're going to set up the recipient initially, and they're going to be the one that can actually take the tokens that are swept. We have a function here for set underlying, so that's the underlying token that we've discussed above. And this is basically we're going to have an address for the latest token that exists. And as long as the underlying token, the underlying variable above that address equals the address 0, then it can continue. If it doesn't, then it's already set. And if it does, then continue. And it'll have this underlying variable adopt this new latest token that's basically instantiated from this interface. Then we have some funky comments here, which I don't understand. And then we have a function down here, which is a sweep token. So this is the sweeping process. We want to sweep the tokens from this token here. And what we're checking is basically that the token is not underlying. And if it's not underlying, then you can sweep it. And the reason we're checking to see if it's not underlying is this goes back to the DET point. So remember how DET was the underlying token that we're not allowed to touch, but we're allowed to touch the LGT token? If the DET token is here, then we're not allowed to do that. But if it's this, then we can continue and actually do the sweep. So what it's going to do here is it's basically going to say, okay, I want to do a transfer from this token. I want to take the balance of that address and send it to the recipient. And that is Cryptovault. Now down here is where the exploit is, hence all the comments that I've included here, just so I could actually understand what's going on. So quickly we'll go to the top. So we have our contract for LegacyToken. It's inheriting the ERC20 methods so we can actually set up an initial supply here and mint it. We're going to name it LegacyToken. The symbol is going to be LGT. We're also going to inherit ownable, so we can actually put in a modifier as well to ensure that only the owner can touch things. We have a variable called delegate, which is inheriting the interface, the delegate ERC20 here, and you'll see where this comes into play later on. We have a function called mint, so we're going to mint the tokens that we've just discussed above. So we're going to mint those to this address, this amount of what we want to mint, and this is only owner is allowed to touch this. And remember, this ownable piece is something that we've set up an interface above from the ownable. We've imported the ownable piece from, I think it's OpenZeppelin, where it allows you to create these modifiers. So as long as you're the owner, then you're allowed to do this minting process. So once we mint it, we're going to say we're going to mint it to this location, this amount. We have our delegate to new contract. So this is taking two variables. It should only take one. So I think it's taking the new contract variable, which is maybe instantiating from this delegate ERC20, and then we're going to pop that into this delegate here. And then this is where all the magic happens. So I'm going to delete all that stuff. This transfer is what we care about, and this is what we're going to exploit. And the reason we can exploit this is if we look at this, we can see it's a transfer, and this transfer function is saying I want to transfer to this location this amount. And this can be overridden and returned, and what it returns is a Boolean, so if it worked or not. Here it's going to check to say, okay, is the address delegate equal to the 0th address? So as long as that equals, as long as the address that's calling this transfer matches the delegate here, then we'll allow it to continue. If it continues, then what it's going to do is it's going to do a super transfer to this location, this amount. So I needed to understand what super meant. I didn't understand that, so I found this link here that I'll share in the YouTubes. And this link basically explains you to what super is. At a high level, basically what it's going to do is it's going to go to the base contract and utilize that transfer instead of the transfer that's called out inside of this contract. So when it does super, it's going to go to, I think it's going to go to the delegate ERC20, which has a transfer inside of it. And we're going to do the transfer from there, or use their transfer instead of ours. We're going to do else, and this is basically going to do the delegate transfer. So this is what's going to be exploited. And the reason this is exploited is basically when we do the delegate, it's delegating the transfer, which refers back to the delegate transfer here. And it's going to say to this address, this value from the sender. Now, when we do this, we're going to transfer the LGT, but you'll see below in double entry, when we're transferring this via the delegate transfer, we're also going to transfer the DET as well. So that's going to allow us to sweep both tokens simultaneously because of the mix-up in the code here. And this reference here, I kind of skipped over it, but this reference is one of the solutions that I'll point you to. And this is Dalton something, Dalty Boy 11, and they basically walk you through specifically why this is exploitable and how you can exploit it. All right, this contract here, DoubleEntryPoint, is inheriting ERC20. It's also going to inherit the delegate ERC20 interface as well as the ownable import that we included. A few state variables. So we have, you'll see how all these come into play in a second in the constructor, but we have a Cryptovault, which is an address, a player and address, and a delegate from address, and then we have Forta, which is going to be encompassed in this variable here. Our constructor here is when this contract is initially deployed, it's going to take in a few variables. So first it's going to take in a lot of the addresses we just referenced. So LegacyToken here, vault address, Forta address, and player address, all of these are going to be tacked against these variables we just established. So you can see that all done here. So you can see LegacyToken goes to delegate from. So this is the LegacyToken we're being pulled from. The Forta address is going to be put into the Forta variable and instantiated by the Forta interface. We have our player address, which goes to player, and then a vault address goes to Cryptovault. We're going to mint the Cryptovault via 100 Ether. That's going to go into that vault as well. So this is the constructor piece. That's what's happening there. Our modifier is basically stating that you can only delegate from certain locations, and that's only delegating from the legacy token. And that's saying that as long as the delegate from address equals the sender, then you're allowed to continue. If not, then there's this is not a legacy contract, so you're not allowed to touch it. We have another modifier here, Forta modifier, Forta notify modifier, and this is, I think, this is directly related to the detection bot that we talked about with the interface above. So this is an address, and it's going to take the player detection bot Forta, put it into this variable, and then you can see the comments here that we're going to cache the old number of bot alerts. So any bot alerts that have triggered previously, we're going to put that into the previous value of here. So we're going to take the detection bot, we're going to take the number of alerts raised from the method from this interface we discussed above. We're going to put it into this variable. We're going to notify Forta if anything happens. So if there's a notify for the player, we're going to send that message data to them, and then we'll continue execution if that once that notification occurs. And then at the end, we'll check to see if any alarms have raised. So that's basically saying if the detection bot has triggered an alert based off of the number of alerts that have been triggered, if that's above the previous value, then we know alert has triggered, and then we'll let them know. And last, we have a function on here, which is delegate transfer. And this is referring to the delegate transfer that we're going to take advantage of above. So if I go back up here really quick, you see this delegate transfer that I talked about that we're going to exploit. That basically comes down here, and that's where this comes into play. And we can see down here where there's a few variables that are encompassed, or parameters inside of this function. Who we're sending it to, the amount we're sending, and where it's coming from. This can be overridden. It states that it can has a modifier here, so only the delegate from address is allowed, and Forta notify is going to be triggered as well when this happens. It returns a boolean if it actually worked out or didn't. And then basically you can see the transfer here saying it's being transferred from this location to this location for this amount of value, return true if it worked. So that is the code setup, and those are all the contracts encompassed in this big blob of text. Like I said, this is where the exploit comes into play, because if we exploit one token LGT, we're actually going to sweep DET as well. And our goal is to set up a bot that when this occurs, when this transfer triggers, then we trigger an event and say, you know, this sweep happened and it shouldn't have, and then, you know, notify the person that should know. So if that's the problem, and that's the exploit, we found the first piece. The first piece was basically to find where the exploit lies. So now that we found where the exploit lies, our challenge is basically to create a detection bot that allows us to detect on that specific event. Now, this code here, I pulled from this resource, Tony. So I want to give a shout out to this person because I think that they're the only, so I did a lot of Googling first off, and I looked at Google, Bing, DuckDuckGo, Brave Search, Start Page, a ton of different search browsers trying to find answers to this problem, and I only came across two. So huge kudos to both of these people. This individual, Tony, they basically pulled together a series of challenges, or a series of solutions to the challenges, and they did it in a pretty succinct way. A lot of it via code. And inside of their solution, you can see that in the contracts piece, they have their detection bot written out here for Sol, and that's what we're looking at above in the solution here. So for creating the detection bot and triggering on the events that we just discussed, we're going to set up Pragma. We're going to import a few things. So we're going to import DoubleEntryPoint.sol, which is referring to the eth.sol here. We're going to import Hardhat, so they're going to use Hardhat to do their tests here. And they have a contract. So the contract here is basically a detection bot, and it's going to inherit the interface, which is being pulled from here, which is the detection bot interface we've talked about already. We have a vault variable that's an address, which is private. Our constructor, which is going to take that address vault, we're going to attack it against that variable. And now these comments here are important to understand. Reason being is that this function here correlates directly to this. So I'll talk about the comment in a second, but I want to talk about the function first. So our function here is handle transaction. This handle transaction is basically a function set up to trigger on an event if a certain thing occurs, which is kind of the whole bot process or premises. So we have our address, which is the user, and that's going to probably be us, so we can be notified. And then we have the message data that we're going to send to this user when that thing triggers. So in here we can see that the variables being set up inside of this function, or the parameters, are going to be where this is going to be sent to, so the address to, the amount of value, and the original sender. Now, all these variables are being pulled directly from the delegate transfer that we just discussed. And these are the things that we want to trigger on. So when we want to trigger on this, what we have to do is we actually have to decode the bytecode to ensure that we're pulling out the correct information. So when we trigger this bot, it's pulling in the right information to the user that needs to know what message data, what's occurring. So here you can see what they did is they did inline assembly. And this inline assembly is basically pulling out each one of these variables via the hex code that's available. And you can see this variable here too is going to pull the data from this slot location. This value is going to pull from this slot location. This value is going to pull from this slot location. And when you pull from those slot locations, it's going to pull in that specific data set. Once you've pulled in those data sets, it's going to say, okay, as long as the original sender equals the vault, then I want you to raise an alert to the user via the message sender from the Forta piece. Now, these slot values, we got to ask ourselves, how did they get these? How did this happen? Well, if you look at this layout here, you can see the call data layout. There's two functions that are included here, so in the slots that we need to consider. So the first function is the one that we just created, so handle transaction, we just talked about that. And the other one is the delegate transfer. And this is the one that we care about, and this is what we've already discussed, where that's where the actual transfer is occurring, and that's where we're going to do the sweep of the DET and the LGT tokens. And here you can see that of these slot locations, we have the offsets, and the offsets basically where that data sits. So starting from 00, that's where this function signature is going to sit, so it's going to be at the very beginning. Next piece is the 04 slot, and that's going to be the user address, and that's going to be sitting at this location here. And you can see that these, this is the length, this is where it sits, and that's kind of the understanding of how this data is located in each of those storage slots. So here, we can see that at this location, this is where our signature is where we care about pulling this information in. So this is the function we care about, and this is the signature for that function. We know that from this slot location going forward, 68, 88, and A8 are all going to include the variables that matter most to us. And most importantly out of all of these is that A8, we can see that the original sender is the variable that we want to pull out. And that's an address, and it's a 32 slot address, which is going to sit somewhere, something like this. So that's those are the bits of information that you can pull from there. And you can also watch previous videos where we used, I think it's like Get Storage app on Web3.js, where you can actually pull the storage locations of where certain items are, and you can figure out where that is via the console. So that's what's happening with this bot. This bot's basically going to pull that information out and trigger the alert. And once it's triggered the alert, it's going to trigger it specifically on the event that we talked about. So if somebody tries to exploit this, they try to sweep LGT and get DET, they're going to eventually call this delegate transfer, which is what's going to be pulled out of here, and it's going to trigger on this. So that is the bot, that is the exploit. These are the solutions. So I've already showed you Tony, and this is the Dalty one. So they basically walk you through the exploit here of specifically what's vulnerable. And then they show you their kind of explanation of how they would do the bot. I preferred to show Tony's because I thought it was easier to explain, so you can check out both if you'd like. But yeah, that is going to be it. This is the final challenge of Ethernaut series, giving the explanation to why we didn't finish it. Hope you enjoyed the series. I will see you on whatever I do next. I'm not sure, but it'll be fun. See you around internet.